So what is malaria? Malaria is a disease of the blood that is caused by Plasmodium parasite, which is transmitted from person to person by a particular type of mosquito. The female Anopheles mosquito is the only mosquito that transmits malaria. So let's look closer at the malaria parasite. There are more than 100 species of malaria parasite. The most deadly and most common in Africa is known as Plasmodium falciparum. Once the parasite enters the human body, it lodges itself in the liver, where it multiplies approximately 10,000 times. 2 weeks after entering the body, the parasite bursts into the bloodstream, where it begins infecting the red blood cells. Over here on the picture, we can see the parasite, which is in blue, next to the red blood cells. On this slide, we can see the Plasmodium parasite. And we can ask ourselves, what is this Plasmodium? Well, it's not a bacterium or a virus, but it is a eukaryote, just like us. However, unlike us, it lives a solitary life as a single cell. Over here, we have a picture of Plasmodium. So now, let's look closer at the malaria parasite cycle. A female mosquito carrying malaria-causing parasites feeds on human and injects the parasites into the form of sporozoites into the bloodstream. The sporozoites travel to the liver and invade liver cells. After 5 to 16 days, the sporozoites grow, divide, and produce tens of thousands of haploid forms called merozoites. Some malaria parasite species remain dormant for extended periods of time in the liver, causing relapses weeks or months later. In the next stage, the merozoites exit the liver cells and re-enter the bloodstream, beginning a cycle of invasion of red blood cells, asexual replication, and release of newly formed merozoites from the red blood cells, more or less every 1 to 3 days. This multiplication can result in thousands of parasite-infected cells in the host bloodstream, leading to illness and complications of malaria that can last for months if not treated. Some of the merozoite-infected blood cells leave the cycle of asexual multiplication. Instead of replicating, the merozoites in these cells developed into sexual forms of the parasite, called male and female gametocytes, that circulate in the bloodstream. When a mosquito bites an infected human, it ingests the gametocytes. In the mosquito gut, the infected human blood cells burst, releasing the gametocytes, which develop further into mature sex cells called gametes. Male and female gametes fuse to form diploid zygotes, which develop into actively moving okinetes that burrow into mosquito midgut wall and form oocysts. Growth and division of each oocyst produces thousands of active haploid forms called sporozoites. After 8 to 15 days, the oocysts burst, releasing sporozoites into the body cavity of the mosquito, from which they travel to invade the mosquito's salivary glands. The cycle of human infection restarts when the mosquito takes a blood meal, injecting the sporozoites from its salivary glands into the human bloodstream. So what are the malaria symptoms? Well, there is few stages of malaria symptoms. There's a cold stage, which is being represented by chills and shaking. Hot stage, represented by fever, headache, vomiting, and sometimes seizures when the small child is infected. The next stage is a sweating stage, and we feel very weak and we sweat profusely, like literally dripping with sweat. And then the next stage, we we feel well for a period of time, and then the cycle repeats itself. As mentioned before, in the red blood cells, they are being released every 1 to 3 days. So how can we detect malaria? Well, first of all, we have to be aware where we're traveling. And if we develop the symptoms like sweats, headaches, muscle pains, nausea, and vomiting, when we go to the doctor, we have to tell him if we have traveled into the malaria danger zone. Because very often it happens that in Western cultures where there is no malaria present, the malaria can be misdiagnosed for a common flu. Once, if we inform the doctor that we actually have been to the infected area or we are in the infected area, malaria parasites can be identified by examining under the microscope. They take so-called a blood smear and just examine it under the microscope to look for the Plasmodium parasites. In some cases where there is no good access to microscopes, there are antigen detection kits, but they are still under testing and they are not very reliable. However, they are available and they can help with an early detection of malaria because they can produce results in about 2 to 15 minutes. Now let's focus on the treatment. The choice of drugs depends on the species of Plasmodium and if it's drug resistant or not. The risk of drug resistance depends on the area where the malaria was acquired. For example, in sub-Saharan Africa, all the drugs like chloroquine are largely ineffective. Most medications are available only as tablets or pills. Intravenous treatment with quinidine may be needed if severe malaria occurs or when the patient cannot take oral medications. Here's the list of some of the drugs below, like for example, Lariam, Qualquine, and other ones. The fun fact, the main active ingredient of all the anti-malaria drugs is quinine, which can be found in tonic. It gives tonic its bitter taste. Another fun fact is that quinine is fluorescent. If we put tonic water under the UV light, it glows. That's the presence of quinine. So how can we prevent malaria? Well, basically, don't get bitten. The malaria is also transmitted by blood, but we would have to come in contact with infected blood, and the blood would have to be introduced into our bloodstream. So the main thing is don't get bitten by a mosquito. And we can use just the normal protective measures as insect repellents, long sleeves, long pants, sleeping under mosquito nets. And there is no 100% approved working vaccine for malaria. It's under research. The research is being done on it. Some of the vaccines are actually in a trial and test stages, but there is no official one on the market yet. Let's look at malaria in numbers. According to the latest estimates released in December 2014, there were about 198 million cases of malaria in 2013 and estimated about 584,000 deaths. Although the mortality rates have fallen by 47% globally since 2000 and by 54% in the WHO African region, malaria is still one of the biggest killers in this area. The drop in deaths was mostly acquired by preventative measures, distributing the anti-mosquito nets and spraying the areas for mosquitoes, just killing the larvae and killing mosquitoes. So, who is the most vulnerable? Well, these are the people with no or little immunity against the disease. And um, the groups can consist of young children who have not yet developed partial immunity to malaria, pregnant women, travelers or migrants coming from areas with little or no malaria transmission. So let's look at the map of malaria. Well, the malaria transmission occurs in all six WHO regions. Globally, an estimated 3.2 billion people in 97 countries and territories are at risk of being infected with malaria and developing the disease. And 1.2 billion are at high risk of getting it. But basically, looking at the map, it's mostly the African region, South America, and Asian regions, everything where it's close to equator, where it's hot and moist, where the mosquitoes thrive. Thank you for listening, and I hope you enjoyed it.